Hello everyone and welcome to section 7.3 and 7.4 day 1, which is on similar triangles. So let's start off with a couple of postulates and theorems. Our first postulate says that if two angles of one triangle are congruent to two angles of a second triangle, then those triangles are similar. This is also called angle-angle similarity or AA similarity. Theorem 7.2 says that the corresponding side lengths are proportional, or if the corresponding side lengths are proportional, then the triangles are similar. This is called side-side-side similarity, or SSS similarity. And theorem 7.3 says that if two sides of one triangle are proportional to two corresponding sides of a second triangle, and the included angles are congruent, then the triangles are similar. This is called side angle side similarity. So this is very, very similar to the setup of side angle side congruency, where you have two sides of a triangle that are proportional and those angles are in the middle, in between those two proportional sides. For theorem 7.4, I do have some other properties that have kind of carried over and apply to similarity. The first one is the reflexive property, which says that triangle ABC is similar to itself. Next, the symmetric property says that if triangle ABC is similar to DEF, then triangle DEF is similar to triangle ABC. And, of course, the transitive property that says if triangle ABC is similar to triangle DEF, and triangle DEF is similar to triangle XYZ, then triangle ABC is similar to XYZ by the transitive property. Okay, let's do some examples. Number 1, we have to determine if the triangles are similar and then determine the similarity statement. So we're going to use angle-angle similarity, side angle side similarity, or side 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 similarity. So let's look here. Right off the bat, I see we have some vertical angles that I know are congruent. And we're told that these lines are parallel, which means that we have some transversals in here. So these parallel lines are cut by a transversal. It could be any of these lines going through. I'm going to choose this one, which means that we have some congruent angles, which would be this one and this one. And those are congruent because they are alternate interior angles. So these two triangles are similar by angle-angle similarity. So let's write our similarity statement. Triangle XYZ is similar to triangle WVZ. Make sure you get those corresponding parts matched up. Angle X here is corresponding to angle W on the other triangle. So I made sure to list both of those first. On number 2, we have two triangles. What I'm going to do really quick is I'm going to separate these triangles into two separate pictures so I can see them better. So that's my first one. We'll label it. This is BAC. And let's highlight my bigger one. If you have a hard time visualizing this ever, I would just do what I'm doing and draw it out separately. Okay, so they both share an angle. They both have an angle A. So angle A is, of course, congruent to itself. But to say that these triangles are similar, I need to have at least two other sides or another angle, and I don't have enough information to say any of that, so I'm going to say that these are not similar. Just because I don't have enough information. Okay, number 3, let's break down some information. I've got two congruent angles, so angle ABC is congruent to angle DBF, angle DBF, cool. So far, one congruent angle, great. I have a lot of measurements in here that I'm going to check and see if they are proportional. So if they're proportional, then I can prove using either side, 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 or side, angle, side similarity. So let's check those. I'm going to first compare CB, which is 10, to the corresponding side, which is DB. Those two sides are corresponding to each other. So let's write a proportion using those two sides. I'm going to put DB over CB, and DB is 6, CB is 10, and that simplifies to 3 over 5. So that's my first proportion. Let's do a second proportion. I'm going to compare this side, which is 9, to the length of that whole side, AB, which is 9 plus 6. So let's write that out. First one is BF over AB. BF is the 9, that short part, the light blue, and AB is the 9 plus 6, which is 15. Again, simplified, these are both divisible by 3. 9 divided by 3 is 3, and 15 divided by 3 is 5. So we do have two sets of sides that are similar to each other, and our angle in between is the same measurement. So these two triangles are congruent by side, angle, side similarity. And let's write our similarity statement. Triangle ABC is similar to triangle FBD. Okay, number 4. So this one I don't have any angle measurements, but I do have a lot of sides. So let's start comparing those side measures and see if I can prove that they are proportional to each other. So let's look at our corresponding sides. So far it looks like JL and SR are corresponding, so let's write those. SR over JL. Well, SR is 4 over JL, which is 10. That simplifies to 2 over 5. First proportion done. Let's do it again. I'm going to compare now RQ and KL. RQ over KL. RQ is 6, KL is 15. Reduce those are both divisible by 3, so I'll get 2 over 5. So far, so good. They're all the same. And last one is JK and SQ. So my proportion is going to be SQ over JK. So SQ was 8 over JK, which is 20. Those are both divisible by 4, so I get 2 over 5. So my sides are all the same proportion. They're all 2 over 5. So these triangles are similar by side, side, side similarity because my sides are all proportional. So let's write out my similarity statement. Triangle JKL is similar to triangle SQR. Okay, for 5 and 6, I first need to identify if the triangles are similar. So, and then I need to find the length of each measure. So for EG, I am told that there are 2 congruent angles. Those dots mean congruent angles. And I have another set of congruent angles that are vertical angles. So these triangles are similar by angle, angle, similarity. And I need to find the length of EG, which is this side here. Well, EG is corresponding to this side right here, which is ED. So, since my triangles are similar, I know that their corresponding parts are proportional, or their corresponding sides are proportional. So, I'm going to make 2 proportions to solve for my missing variable x. So my first proportion is going to be using my missing side, which is x, over the corresponding side measurement, which in this case was 10, and set that equal to another proportion that has both numbers, no variables in the second proportion. So that will be using 2 other corresponding sides. I'm going to use FG and CD to figure that out. So FG was 6 and CD is 15. We can reduce 6 over 15. That will reduce to 2 over 5 equals x over 10. Now when I have a number below variable that's being divided, I need to multiply by that number to counteract that division. So when I do that, those 10s go away and I'm left with x equals 2 times 10 is 20 over 5. And 20 over 5 reduces to 4. So x is equal to 4. So first let's prove that these triangles are similar. Since I have these two parallel lines right here, that means I have transversals. My transversals in this case will be first this green line that I just highlighted. So that does bring some congruent angles. I'm going to look specifically at that angle, QRS, and the second angle, RPT. Those are the same. My second set of congruent angles will be using my other transversal, which I just highlighted in orange, and that would be angle RSQ and angle STP. Those are the same. Those are both corresponding angles. So I've just shown that these pictures are similar, or these triangles are similar by angle-angle similarity. Since these two triangles are similar, that means that their corresponding sides are proportionally the same. So let's make two proportions to find our missing side, x. Or actually, we need to find st, but to do that, we need to find x. So I'm going to make a proportion using x. X is right here, it's side QS. That's going to go on the top of my proportion. The bottom of that is going to be the corresponding side measure, which is, in this case, 20. 20 goes on the bottom. And that is equal to a second set of, or a second proportion for two other corresponding sides. In this case, I'm going to use 12 and 16. So 12 goes on top, 16 goes on the bottom. I can reduce 12 over 16. Those are both divisible by 4. So when I reduce that, I get 3 over 4 equals x over 20. Multiply by 20 on both sides to counteract that division. So I get x is equal to 60 over 4, which reduces to 15. So x is 15. Now back to actually answering the question. The question is asking for st, which is this portion right here. Well, I just found out that x is 15, which means that that missing portion st has to complete that 20, so which means st is 5. Whoop. Okay, number 7. So I need to find the lengths of two sides on this one, but before I do that, I need to show that these triangles are similar. So I'm already told that this angle ZWU, is congruent to this angle, which is WYU. So those are already marked congruent. And I do have another set of congruent angles. Those would be this angle, ZUW, and the one right next to it, YUW. Because those are a linear pair. If one's 90, the other's 90 because they're supplementary to each other. So I've shown the triangles are similar. This would be, again, by angle-angle similarity. Now that I've shown these triangles are similar, let's set up our proportions. So I'm going to set up two proportions for my variable x. WZ is corresponding to WY. I know this because they're both opposite the 90-degree angle in their respective triangles. So that's my first proportion, 3x minus 6 over 40. That's going to be equal to a second proportion. This proportion is going to be ZU, and we'll do UY. So ZU was x plus 6 over UI, which is 32. So this one I have two variables on both sides and two numbers on the bottom. So I'm going to need to multiply this twice. The first one I'm going to multiply by is 40 to get rid of this 40 on the bottom here. So when I multiply by 40 on both sides, I get 3x minus 6 equals 40 times x plus 6. Oh, I forgot the 0. 40 over 32. Before I go and multiply by 32, I'm going to notice that 40 and 32 are both divisible by 8, so I'm going to reduce those, and that will reduce to 5 times x plus 6 over 4. 3x minus 6 is by itself on the left side still. Now, instead of multiplying by 32 on both sides, which I could have done, it just would have been a little bit of extra work, I'm going to multiply by 4 now because I reduced that. So if I multiply by 4 on both sides, I end up with 4 times 3x minus 6 equals 5 times x plus 6. Let's distribute these. First, let's distribute that 4, and I get 4 times 3x, which is 12x, times 4, or minus 4 times 6, which is minus 24, equals, now we got to do it to the right side. 5 times x is 5x. 5 times 6 is 30, so plus 30. And now we just solve for x. I'm going to subtract 5x from both sides. So I get 7x minus 24 equals 30. Add 24. So I get, I'm going to kind of move over here a bit. So I get 7x equals 54. Divide by 7. X is equal to 54 over 7, which isn't a great number, but that doesn't reduce anymore, so I'm going to just leave it like that. So that's my x. It's not asking for x, though. It's asking for WZ and UZ. Well, WZ, we'll do first. WZ is equal to 3x minus 6. I now know what x is. It's 54 over 7. So 3 times 54 over 7 minus 6. Okay, now that we've plugged in our x, let's simplify this. 3 times 54 over 7 is, 54 times 3 is 162 over 7, minus 6 is 120 over 7, I think. So that's WZ, not a great number, but not terrible. Now we need to do it one more time and solve for UZ. UZ is equal to x plus 6. And x is 54 over 7, so plus 6 is equal to 96 over 7. So those are my answers. Not great, but again, could be worse. And that's it for day 2. Like, comment, and subscribe, and I'll see you guys later. Bye.